No, I placed this photo above the wall in order. Next video, I hope next video will show this, and I mean like preview video will show this, and it will be rather easy to distinguish that it's your class about jig. As we just talked about, as we agreed about, we are going to talk about the jig, but not about jig design. Yes, we need to mention jig design, like we keep it in mind, but mostly we are going to talk about jig mounting, how to assemble jig, literally, and what are the rules, what is activity before we start produce jig and assemble jig to provide coordination, mating, matching, coincidence of separate jigs. They are separate, like wing, center wing, fuselage, stabilizer, separate jigs in order they give mating objects at junctions. Maybe it was too difficult sentence to understand. No, once again, try to remember, to recollect and try to understand. Jigs are responsible to produce separate pieces of airplane aggregates that next in fuse manufacturing they are meeting and joining by places of junctions, whether it's flange junction or fork junction or telescopic or whatsoever kind of junction, we need just attach two pieces and they are no, like coincide, mating, matching, whatever you say, automatically. At sizes, they are identical. Uh, Objects of junctions, they are different in shape, like left and right side, for instance. But whatever shape is different, the places, surfaces, holes, axis of holes that must be common, must coincide. They should be, it's called coordinated before. And what we are going to talk about is about jig mounting and coordination. How to provide this coincidence of fuse assembled objects, pieces of aircraft, aggregates, units, whatsoever, due to coordinating of jigs. I hope you understand the general idea. What we are going to talk about, and first we need to recollect what do we have in terms of jig, assembly jig, what do we have? What jig consists of? That picture brightly, as for me, illustrate what we have in jig. Look, in a jig we compulsory have so-called skeleton. We call jig skeleton either frame or column beam skeleton, carcass of jig. Problem is that in English language, there are no another word for this frame, let it be. In our language, we call it rama, and frame in air, it's called spangold. We have two different languages, two different words, forgive me. We have two different languages, by the way, Ukrainian and Russian, but in both of languages, it's the same, sounds the same. Rama and spangold. And in English, they use the same word for two different concepts. So time to time, if I pronounce frame, do distinguish, please. Maybe I'm talking about jig. Don't think that I'm talking about aircraft structure. Sylvan, clear what I'm trying to say? Sylvan, hello. Don't be afraid. Yes, it's seconded. Don't be afraid to answer. Sylvan. Sylvan. Sylvan sleeping. Sylvan, your mic is off, maybe. I hope you heard me. Okay, someone don't like to collaborate, maybe. Once again, jig consists of carcass or skeleton, which may be of different type. Either it's produced in tool shop, produced completely a whole piece, and in this case we call it frame-like skeleton, frame-like carcass of jig. Or another variant, it's produced by pieces, columns separately, beams separately, like we did it in our laboratory work about instrumental stand and loft conductor and other elements of G. What is next? No, actually, the skeleton is very important portion of the jig, but not the uh, it's not the element that we really need for locating, for providing of interchangeability and coordination of our aircraft pieces, aircraft aggregates, units. The most important in a jig element, locator or system of locators. In those jigs that you see in front of you, we see locators, some of them still closed, couples of locators that might be called fixing arm in some literature. These fixing arms, they are locators of contour. You see, they are repeating the contour of this, maybe it's wing, maybe it's stabilizer, maybe it's fin. More probably it's a wing of little aircraft. And couples of locators on both of sides you might see here and there. And you see things like empty places, rather similar at this place. I hope you see it clearly. Rather similar places to locators, but we not see locators. Actually, locators at those places exist and they are opened right now. They are put up in the jig. Next jig behind of the jig, you might see on the on background of the photo, you might see the whole fence of these locators. In next jigs, locators are put down and closed, and in this jig, it just put up. And also, you might see a lot of those locators, each maybe 20 centimeters. So considering the another objects in the photo, we might understand that distance between locators is around 20 centimeters. How we might understand it? For instance, by this staircase. What the jig has arrangement like skeleton, locators, supposed to be clamps, and plus to this we have so-called auxiliary devices. Here you see a very good example of these auxiliary devices. Look at this. They are, seems like a table with staircases, with long stools or benches, but really it's not. It's special platform in order employee may stand on this platform and work with elements which are higher than plane of employee side, let it be. It's no, it's not really the second floor. Yeah, you might understand. Approach the level of person knee, or even this workbench. It's even a little bit lower than person knee, than like average man knee is around 40 centimeters. In order you step in with this, step on, let it be, easily without significant effort. Moreover, you have something in hands at this moment. And this platform is even lower. Yeah. So by the comparing, like we may imagine, looks like by comparing of sizes of objects, we might understand the distance between locators is rather close. What it talks us about? It was assembly jig by airframe, so called. Now, these assembly jigs that work with thin skins, maybe, no? And in such assembly jig, we start work with transversal elements, like we're locating the ribs, locating the frames, rims, whatsoever. And next we're locating stringers, and next we're covering everything with skins. More probably it was a jig for locating by, as I said you, by elements of airframe. When we're watching some structure of jig, we need to understand what assembly methods more probably being in use. Considering how many locators they have in those jigs, as I already said you, it comes about the jig by airframe locator. That one also for wing, for wing of little aircraft. I've created something like a fighter, considering the shape of this wing and the size of it. Or it's maybe even stabilizer. It's not compulsory a wing. Comparing with size of human, yes, it's not enough to be a wing, even for fighter, modern fighter. More probably it's stabilizer. And pay attention, how many contour locators it has. One contour locator is here, what here is, we see contour locator. We see contour locators, couple of contour locators at this place. Also, they are put up and closed. And finally, one more locator, couple of locator will be here at the end. And to compare these distances between contour locators, what like almost the human height, what in width, between locators here and there, and and to compare these fans of locators, what literally fans of locators. Quite clear it comes about different assembly methods. Here, assembly method by skin, or they are starting with locating of skin here in this jig. Jig looks too much complicated, but mostly it's because of this. Look at this junction locators. It has fork-like or eye-type locators to the fuselage, certainly. Big brackets that looks like forks. They have what that is also. It's easy to distinguish what kind of locator even by additional elements. Look here, something like a wheel at this place to move locator to back to forward. No, like backward, downward in this direction. And here is also visible some elements like wheels. No, maybe you do not recognize them as wheels right now, but as far as I've seen hundreds of such jigs in real, in photo, I might understand what it comes about. It's locator of junction. At this place, they have locators of junctions. Complex structure, of course, yes, but. And to pay attention again, employee by the word. He's seems like he's half broke the safety rules. He has special platform near the jig, and he has special staircase, something like double stool near the jig. But look at him. He used simple, no, we call it cubic. This cube, it's mostly it's used for sitting on. In order, employee may work conveniently with lower elements. By the word, at the bottom, it also has some locators of junctions. But pay attention. No, maybe it's not good visible. Here is one, second, third, fourth, no, a lot in front of this place. It's around, no, like on the front spar. I see around 6 places where something rather similar to locators of junction. That one is also movable locator of junction. Very interesting was it. What really supposed to be in front of this aggregate that they assemble? Pay attention once again. He stay with one foot on the cube with another on the frame of the jig. Actually, it's not supposed to be like this according to safety rules. Well, maybe he just trying to save his time. Maybe. By the way, here is the picture of exploded view of the structure that they assemble and picture of airplane. And yes, it looks like a fighter. It's not normally distinguishable because of quality of photo. What is here? But we might understand that here is breakdown view or exploded view and the airplane itself and some description. Now, Your Highnesses, of course, it's not source of information, it's just illustrative material for those who may visit the shop, let it be. Now, my dears, once again, auxiliary devices. Look, auxiliary device may be Silvan, do you hear me?
Yes, ma'am, I can hear you.
Before this, I will asking question and you didn't reply. Something wrong happened with your internet, ma'am, right?
Yeah, actually, no, it's
Okay, okay.
raining, so my power got cut off.
Yeah, 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 yeah.
My
I
power
see
off.
that.
So I
Uh-huh.
converted
Look,
my mobile data.
uh-huh. And auxiliary devices, once again. Look, auxiliary device may be in the view of local light. Now, what you see, bright lamp here. It's rather normal light in a shop, normal, but to the place where people work in order to reduce this visual concentration, visual problem. Additional light here we see additional lamp here, certainly somewhere here we see additional lamp, and here is some some box with digital, with these dials. It means that maybe somewhere here in this jig it's used as an electrical network separately. No, like they have some electrical devices. It might be even drilling inbuilt into jig drilling device. Might be. Or it may be something that related to hydraulic devices. For instance, some of these locators, because of their heavy weight, are driven by hydraulics, for instance. And at the top of jig, you see also the system of ropes or wires, something like this, which are joined to the top beam of this jig. Seems like, no? More probable this place it's even, no, I can't say it's for sure. This place even openable. It means that it's maybe what the whole this beam, it may move up and down in order to remove wind from jig. I'm not see any hinge here. Maybe I'm wrong. Maybe it's not movable. But for some reason, you might see that they have here additional devices, and these additional devices, they look like devices for rotating of this top element. No, I'm not seeing any hinge on this beam. If it's openable, then here they have something like a hinge. I'm not seeing something similar to the hinge. No, maybe I'm just not noticing. And do compare, please, this structure, skeleton, carcass of this structure to carcass of this structure. That is so-called frame-like structure, where it's visible that the whole carcass is assembled preliminary, like one piece. Look, this column and beam, what column, the vertical element, and beam, they are not separate elements. They are not joined with bolts somewhere in assembly shop. They've been produced as the whole piece in tool shop. That one, this place, is joined with bolts, but that place, it's place joining the frame-like structure of this carcass to the stands in a shop, you might see. But here is something like stand, fundamental, platform. And the frame-like structure, the whole rectangle of the jig, what whole skeleton, this one, it was assembled with these additional elements, with these connectors, fork-like connectors, you might see here. And to pay attention, these fork-like connectors, they have tails which are already hidden in these little, let's say, barrels, as we call it, in our laboratory classes, in our literature. Pieces of pipes that welded also, even, even in this low quality photo, it's visible that these barrels, these pieces of pipes, they are roughly welded by arc welding. Pay attention to the width of seams, of welded seams. Yeah? There are places where those things are welded to the lower beam and to the upper beam. It's good visible. No, at the top there is no such visible elements, so brightly visible elements, but here it's visible. And do recollect what I started with, like I said, guys, you have at last, no, what that is photo in our laboratory class, what we were talking about, those barrels. No, I mean, I hope you do remember, mounting the jig by mounting standard, and it's also photo in our laboratory class, but it's another jig that we never used in our laboratory rocks. It's mock-up of jig for the fuselage. And to pay attention also, what do it have? It's for fuselage. Do forgive me, for fin. Must be. I think it's a fin. No, imitation of fin, of course, because the jig, it's when I stand near the jig, I am with my top approximately at this place where the top beam of the jig, it's approximately my height. So it's very little, it's mock-up, skeleton mock-up. And this skeleton mock-up, nevertheless, it has similar things, elements that you see now in black, barrels and fork-eye connectors, which are inserted and fixed with special cement inside of these barrels. And connection of fork eye connector joint with locator itself. Locator is silver like you see, silver color. And it's connected with pins. You might see it. Wait a second, I need to answer to my head of department. Так. And what at the top you might see, it's so-called fork-like junction. White one, it's belong to the structure. Black one, it's locator of the page of the jig itself. At the back side, white colored one belong to the structure. Black one, it's locator of the page in a jig. Why we watch all those diverse design of jigs? In order to make you to understand basic, no, to recollect, to understand basic points. We have so-called skeleton, we have system of locators, and we have auxiliary devices. And all those elements, they should be in proper spatial position. It's also mock-up of the jig, it's not real one, also approximately the same height as me. Pay attention, no, skeleton, of course, welded roughly like the whole piece. Locators, contour locators, we might see here. That is locator which is called jigging plate, not clearly visible for you because when I did this photo, I have no high quality of camera, must be. And aside of it, it's not even locator, it's also auxiliary device. How distinguish where the locator, where auxiliary device, it's another story. Here is drilling conductor in a jig. But now it's I hope it's better visible that you have locator which coincide with one of frames. It's so-called flange junction, please. One, not telescopic junctions of fuselage like we have seen in the movie, of Airbus or something else, but flange junction of fuselage for some reason, whatever this reason is. And you see locator which is called jigging plate, and these bushings, they are for inserting the pins in order to align pieces of frame, because this frame in real, what in real airplane, this flange junctable, let it be, frame, it may consist not from one piece, it may be with diameter 3 meter, with diameter 6 meter, and it means that it might consist out of 4, 6, 10 different separate elements, and all these separate elements supposed to be located with holes in the proper position, and they all must be with the same plane, or their tips, their edges supposed to be in the same plane. It's a special kind of locator. Such special kind of locator in our jig here we had. I hope you do remember that is jigging plate. The plate which actually GBH locator. GBH locator maybe of fork-like type. No, that one, the black one in our mock-up of jig. It's maybe, no, that is also fork-like. It's maybe of flange type, it's maybe of telescopic type, and another things. No, that is the jig also not the best records of it, but it's visible anyway for you. The whole fence, as I usually joking about, of locators. Once again, remind you that who no, that one who have painted this in red color, this one is permanently как ribbing his ears because his ears has problem. I permanently mention this person and mention it like, do forgive me an idiot, because in our jig it's supposed to be of another color, and in a shop, according to our rules, you see at the bottom a red element. It's not for the beauty. All colors, they are talking something to you, and red color, it say I am a tooling for mounting the jig. The one who have painted brightly in beautiful colors these locators have solved the bad service to our students. Normal colors of jigs, they are silver-like, green-like, gray-like, bluish, something like this, but not red. Red, it's only tooling of second order, tooling for mounting the jig. What in particular here we have piece of real mounting standard for the nose wing. And that one, it's so-called mounting plate. What is the difference between jigging plate and mounting plate? No, I hope you do remember. I hope you followed to my command to watch video of previous group. And I hope you have recollected that jigging plate is a piece of jig. It's element of tooling of first order. Mounting plate. What is this mounting plate for? Let's come back to, no, by the word, do pay attention. What this jig? May you say me, skeleton of this blue carcass, this blue skeleton, it's frame-like jig or column beam jig, as for you. So one to try. It's not so big problem to say. So one, how do you think? It's
Yeah.
frame-like or it's column beam?
Yes, ma'am. It's frame
Oh
like.
yes, frame-like. I agree with you completely on this point because we see that it's welded with as a one piece, all this structure, and only place where it's separate something, it's maybe separate something. Those stands now, what it's relied, like place it onto in a shop. Yes, it's frame-like. Do pay attention to this one. It's not visible here. Okay, not visible, not properly visible, and it's also somehow visible, also visible that it's also frame-like. And when it comes about the jig that we have seen here, what that place, certainly we might say it's column beam-like because we see that beam itself, columns, they looks like separate elements, and all the places where they are joined, all these places are bolted. More probably they were assembled in a shop. And that one also have bottom beam, what here is at the bottom. How to, if we, let's think that, that one. Look, the line of these fork-like connectors at the bottom in one beam, let it be, and line of fork-like connectors at the top, and how to place them in the correct position with respect to each other. It should be on some proper height and alignment also with one line, no, in one plane, because if you place it wrong, no? If you place it correct, locators maybe hang it like half automatically. If you place it wrong, otherwise, it means that you can't place locators. You may place locator onto the upper beam, but they will be not placeable inside of this lower beam for connectors. And what do I mean? Now, I asked you to read about methods of coordination. Let's see in the channel exactly, да? Вот. Here is text, it's colored with some definition, but I'm not seeing that here is the picture colored. Somewhere you have in a video, да? You might have even picture colored. Let's steal this picture and let's place it to your group here also, да? Так, something like how to mount the jig in general. Once again, we have system of locators that we need to place into some proper position. And we have skeleton separately, let's say, how to mount the jig. In general, at all, to provide some sizes, to produce something with sizes, we have only two approaches. And these approaches, they are mentioned here. On the left you see by coping, да? On the right you see by measuring. By coping, by measuring. What does it mean by coping? By coping, when it comes about the molding, casting, forging, all those techniques, they are coping techniques. You are coping with part, with the shape of the part. You are coping the shape and sizes of tooling. When it comes about the measuring, no, the most typical example of measuring, it's cutting in milling machine, especially when it comes about CNC machines. CNC milling machine, it's your measuring device, and if you have no CNC, it means that you will measure with simple ruler. I hope you understand. I've knocked the door in order to reduce noises. And have closed. What does it mean by coping in terms of jig? Once again, jig consists of separate pieces. We have seen skeleton, we have seen system of locators. It's not one locator, there are systems of locators. And how we may place them into correct position? By coping of shapes and sizes of real objects. Let's try to draw this real object. It's not real object. We understand it's supposed to be some mock-up. For instance, we made here, do forgive me that I painted with yellow color after I have cursed the one who painted wrong our locators, да? And do forgive me, it's bad picture, let's say, да? Those contours, they are made as imitator, да, substinator, let it be of real wing. No, surface standard was of yellow color, of course, but surface standard we usually not use no, in such direct way. Surface standard, which repeat all the surface, we do not use in such a way like to copy sizes of jig into jig, да? Because surface standard is to repeat the whole surface, but it has no junctions above the wall. It has no gauges of junctions. And in this place, we also need some gauges of junctions, let's add it with some distinguishable color. Or for instance, somewhere here, now we have some substinator of our bracket. Sorry, very beautiful. Next, maybe we will increase it. And what we are striving to, what we are interested in, really, we are interested to repeat this color, this contour, which I'm now painting with red one. Actually, this contour is somewhere here. Yes. I hope you do remember how we do this in our laboratory class, how we did it in laboratory class, how we do it at all. We attach locators. What this contour does is attached to the tooling. We attach locators to the proper places and fix them at the skeleton. Position of holes, which here between fork-like connector and silver, this silver-like element, not silver in my picture. No, let's do it with some another color. Now here, position of holes, those holes which are called mounting holes, they are whether they are whether they are important or their position is important or not, they are called mounting holes. Those holes that join locator immediately to their place here in a bin. And we see barrels that madam is spoiling currently with attempt to do it better. I do it even worse. And those barrels, they are empty. We are not interested really in position of those holes. Locators here, you see, and fork-like connectors, no? But here is, they just hang it here, join it with pins or however, but our position, their position is not interesting for us. Let's drop it. It was one way to know it. What is another way? What is, like, say, in contrary, да? Another way is I forgot. Okay, do it like this. Another way, measuring. Once again, we need to place here locators, those locators. But now seems like we have no any measuring device. And how we're going to repeat those contours? How we interested, remind you, in this contour. How we may find position of this contour. Position of this contour is given with respect to axis. So one remind me, may we use axis in this case as base for measuring? Maybe somewhere here in the jig they also have axis. Do they have axis in the jig, Sovan?
Axis.
Axis. No, I mean, I may show you once again those photos that we have seen in the beginning of class. No, like to remind you, да? Oh, not those photos. No, that is also very beautiful, but not exactly what do I mean. Давайте, let's see. Вот, here is assembly jig. Do you see any axis here? No, no. As for me, no. Here is assembly jig. Do you see any axis here or somewhere in the middle? Where the axis of this silver-like locator? Where the, no, in a drawing we might find it, but in real life, axis does not exist. Even axis of this pin, even axis of those holes that you might see. Axis, it's our imagination. It might be used for showing something in a drawing, for showing sizes, for dimensioning. But in real life, you can't adjust your ruler or any another measuring device to the axis and to the object. To the object, yes, you may, but not to the axis. It does not exist in real, yes? And seems like task became unsolvable. We are going to measure something from axis, да? You see, from axis to the contour, and each time we are going to measure it in a jig in some, maybe dozens of places. But we have no place where to attach the ruler. Yes? Hello?
Yes, there is no any place to attach the ruler.
Thank you so much. Thank you. At least you remember what I said. Now, how this task is solved? Look, in a drawing we have this axis, but in real, this object, now, or this one, this red one, has no connection to this axis because no axis in real. But this white object, this locator, it might have another element of them, interchangeability and coordination. And usually what do? We do hole, mounting hole with very high accuracy now. No, not in my case, as you might see, with very high accuracy. Now let's try to do it like, it's mounting hole now. Да? You see? And mounting hole we have in locator, and how we actually going to use this mounting hole. I will try to draw right now. But look, we might measure the distance between mounting hole and axis in a drawing, and any point that we have here in not much visible color as a period, I don't know, that one, no? Any point, or that is brighter, that we have at the contour, it may be measured from position of this hole. Now, here you have this size dimension, no? Here, little one, and any point at the contour, it may be measured with respect to another axis. Another axis is axis of mounting hole. It's such trick which substitute one base. Originally it was this base, but now we substituted to this base. Now, of course, we broke principle of locating due to this, and as a result, we have less accuracy of this measuring than if we measure from axis immediately. But once again, remind you, we may measure from axis only in a drawing, but not in real life in this case. Object is far from axis at all in this case. Locator of contour, it's far from axis. Axis is not included into this object at all physically. We can't even draw axis on this object. And now in modern conditions, we might use, for instance, CNC device to provide this coordinating of sizes of this red contour, that one. Once again, let's draw. What we're really interested in this contour. Так? Вот. And these mounting holes, they are substitutors of the axis. Now it's possible to do with very high accuracy in the milling machine with CNC, for instance, or in the turning machine with CNC if it comes about cylindrical surfaces like fuselage fixing arm. But not 40, 50 years ago. There are no CNC then. How people solve this task? Actually, whatever it's called, despite it's called coordinate measuring technique, really they anyway used templates. Templates were carriers of those axes and contours, both axes and contours. Here is the template of contour, template of jig it's called. When it comes about the jig, we call it template of jig. Template of jig, and template of jig has base hole. What is base hole? System of base holes. It imitates this axis, no? Like 2 points that you might draw line through. That is the axis. And also it's repeating the contour. And how it was used? Really, it was used instead of rulers, instead of scale. In order to reduce difficulties, in order to reduce errors and mistakes, simple mistakes, not even errors in manufacturing, in order to produce locator, instead of measuring by ruler, they use template. And the one who produced locator, he just copy down the contour of template. No, like it's not copy down, it might be even measure when producing this locator. Да? But next is compare template finally and position of contour and position of holes with respect to the template. How we did it in our laboratory work, I hope you do remember. We did it in loft conductor. Loft conductor, let's drop it temporarily at least. Oh, I dropped clever me once again. Let's change it. Oh, at least I will restore what I started. Template. Let's take a little bit thicker line. No, oh. When I'm hurrying, it became even worse. Да? Base holes here, так? And we are measuring the mounting hole positions, those holes, from axis that given in the template as a system of base holes. Так, так. Mounting hole. First we have distance to the mounting hole, And next, minus, let it be, like any place in contour, it may be obtained, like size to this position, size, backward, 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 and so on. And as a result, you have this contour finally. No, I hope you see it. Так, once again, here, here, here. So mounting holes now they are serving as substenators of base holes. Yeah? Base holes now we might do everything without template. We just use так, like this. Instead of it's my phone might be in a phone in a bag like big like BB which is located in a box. And yellow one is template of Jig. It's old-fashioned way to solve it. Or instead of template of Jig, instead of it, we might use CNC milling machine, for instance. Yeah? Either or. In order to produce these locators. And what we need to produce in locator accurately, once again, red elements. Contour with mounting holes. Так, уронили. Так, once again, look, either way, copying sizes of tooling by attaching to this tooling, or we are copying or we are measuring sizes of jig. To be frank, in previous years we still use some elements of tooling, but not so complex and not so expensive like mockups. Yeah? And due to this, we might understand where to place this locator, what is the contour of locators and where to place them. And in order to provide correct placing of locators, no, we are forced to repeat this mounting holes positions to measure this mounting hole positions twice. On one hand, we measure contour with respect to the mounting holes in locators. On other hand, we are forced also to to measure holes in forks. They must be in the proper places. And these places, it's like coordinate grid. Here, what I'm trying to show you is like this. And mounting hole. I'm afraid it's became worse and worse, this picture. The mounting holes here and there. Next, we hang one to another, and finally we have the jig. And why I reminded you all this? In order you might recollect, once again, let's go here, about methods of coordination. No, rather similar picture as for me. However ugly it looks like. Methods of coordinations. All the methods of coordination, either you use old names like this LTM, CTM, VCM, STM, and so on. No? Whatever you have seen in our textbook. Or you use new system of names which basically relied upon the like technique of combination or way of combination or pattern of combination, origin of coordination and mean of coordination. Origin is drawing, loft, standard, and program, and mean of coordination either template or mockup. Template mockup for special means, and universal means. They are called instrumental means because they are means of measuring, and there we have the whole good dozen of different means, including the instrumental stand, loft conductor, universal coordinate measuring table, rulers, levels, theodolites, coordinate measuring machines of different types, including laser trackers and so on. We have the whole dozen, I said, means, but they are all about the same. They measure distances, angles, and due to this we recognize where the place of each element, what is the shape of each element, and where the place of each element. Seems like great technique, very cheap, because you don't need expensive tooling, special tooling that you use maybe once during pre-production, and time to time you use it for periodical inspection of the jig. But all the periods between these, it's not in use, but you must save it with very high accuracy and in special conditions. It's like I used to, no, in our language we have such a joke, священная корова. What does it mean? It's like referring to the Indian tradition of, no, I don't know, worshipping, да, for some animals. Sylvan might be, help me. That cow in India is holy animal, and no, at least in some regions, да. And if cows stand somewhere on the road, no, it means that traffic should stop even, but no one dare to touch it. Am I right? Sylvan,
Yes, ma'am. Yes, you're right.
you understand what did I say or not?
We are in the record, right?
Yes, we are under the record. Don't be afraid. Uh, it's understandable what did I said. It's our, no, it's not a joke. It's like we when we're talking about, you should be very accurate. No, you should be very, no, save it intently, да, something, да. We used to say like it's our holy cow. Так. I might be pronounced wrong. Maybe you not understand. Don't be afraid. That creature. Do you understand it? Да?
Okay.
And in India, I said in some regions, these animals, they are what? Look, they are respectable. Да? They are the sort of
Yes.
worship to them. Да? And in our
Yes.
language, when we when we'd like to say that something should be treated very well with respect and accuracy, да? It said, we used to say, you should save it as holy cow. Got it?
Got it. Got it.
No, it's like we're referring to your tradition of worshipping of this. Да? And usually when I say that, what is the way to treat mountain standard? Like holy cow, with very high respect, with respect, accuracy, and so on. No, because you need to save it in the same, no, those things I mean, да? What is red thing, especially this yellow thing. Standard mock-ups of surfaces, of edges, they are saved with very special, no, in special conditions, special temperature, special moisture, and so on. They are saved with very high accuracy, like in order not to injure them, because the origins of all your tooling at all, now for next 20, 30 years, until you're going to produce airplanes, and all this, above the, on one hand, it's very expensive, and saving of them in special conditions is very expensive. On other hand, as only you stopped program of manufacturing, it's already not expensive thing. It's already expensive piece of trash. It's clear. It's clear or not?
Yes. Yes, ma'am.
But if we're talking about measuring devices like instrumental stand, loft conductor, laser trackers, if you change it, the program of manufacturing, you still may use the same instrumental stand, loft conductor, and so on, in order to produce another airplane. So if even object of manufacturing is to be changed, nothing is, no, you are not wasting this tooling, which is universal tooling. So this tooling, however expensive is it, it's a period not so expensive if we're talking about some period of time. I mean, universal tooling, да? But laser tracker. Uh, laser tracker cost, you need some laser trackers in order to work with jigs, for instance, in your shop. no, even one laser tracker. It seems like it's no, at least it's 100 or thousands of dollars or euros. One laser tracker, not much expensive one, да? Just normal laser tracker. And plus to this, you need to buy computers. Plus to this, you need to buy software, no? License of software to continue with laser tracker. But it's not so expensive as using, no, in general, no? As using of special mockups. Because if, as I said, if you finish program of manufacturing of one airplane and coming to the next program of manufacturing, you still may use the same laser tracker. Да? So money that you spent once, you may continue to spend, no, like you may continue to disperse it a little bit to another airplanes. When it comes about special tools, once you spend your money for this airplane, it's already like spent forever, and that's it. Once again, after some a couple more minutes, I will stop for some minutes again, in order to continue. But we will cut the record by this. I hope you understand. All the techniques of coordination, however you call them, in general, at least old-fashioned techniques before appearing of computers and so on. When we work with lofts, drawings and lofts, 50 years ago, all the techniques that been in use, it was not less than 4 different techniques. They been differ, really, they been differ only in the place, no, like in a portion, these principal diagrams of coordination, these approaches to coordination, they've been different only in terms of how to mount the jig. There were only 3 in general approaches. And even the most general, there were only 2 approaches. One approach was measure positions of the jigs. It's appeared later. You see this approach on the right now. What that one that I tried to draw. Let's place it. Oh, that I want to draw at the second, let's say. How we're going to measure position of contours in each particular locator. And next, how we're going to measure position of these I4 connectors in the skeleton of jig in order to hang locators to these connectors and obtain the position of system of locators with correct coordinates. And all these techniques, they used to be called coordinate techniques, coordinate template method, for instance. With the appearing of computers, they have got another names. There are no need any longer in templates, for instance, but idea it was the same. Measure position of contour with respect to the intermediate element in locator, this mounting hole. Measure position of system of mounting holes in a jig frame, in a jig skeleton, and combine one mounting hole with another mounting hole. Locator to боже мой, what happened? Locator to jig. Guys, I do not see screen now. Do you see screen? Hello.
Yeah, we can see screen, madam.
Oh, it might be my phone. Something do. No. I hope you do remember that I'm watching with one eye to phone, and time to time, when I see the picture has disappeared, I'm scared. Так. Do you hear me?
Yes, madam, but we don't see screen now.
No, you see, да. It was some maybe delay in. I will try to start it again. It was some delay, must be in. It said the computer has now switching to the internet. Great, and it means that I'm not able to stop recording. Да? No, it's okay, it's working. No, I don't know what happened, but computer has disconnected for some seconds. Кошмар. Так, all the screen. Now, I hope. Visible.
Yes.
I love it, Так, and once again, measuring technique. The only way. Just measure position of mounting hole in one portion of, like in locators of jig, and in another portion in skeleton, in gearing structure of jig, and combine one to another. Another two approaches, as I said, actually it's the same approach. Idea is copy sizes of some carrier of sizes from from this carrier to the jig. How copy? Attach elements of jig to physical carrier of sizes. The difference, like I said, there are two approaches, but really it's the same. The difference only in, let's jump again to this place. Originally, people has no idea about this mounting standard. Originally, people were not trying to join all the templates. Actually, they are copying what? They have system of templates, and they are copying this system of templates, sizes, and shapes to a system of locators. Yes? But originally, people didn't work like this, like they joined all this system of templates into the one physical device. They've been working with separate templates. We have inherited this technique from shipbuilding, I mean sea vehicles building, and sea transport. And some first maybe 12, 15 years or even 20 years of airspace era, age, airspace aviation age, no, more than 100 years ago, it was accurate enough about the all, and it satisfied demands to accuracy of that period of aviation. And no one tried to change it. They just inherited this technique and they use it. Да? But with the appearing of problem of high speed in airplanes, it was so high speed, да? 300 kilometers per hour, it was great speed, great. Something like revolution, innovation. And this revolutionary speed was resulted in higher demands to accuracy of outlines of aircraft. And moreover, airplanes manufacturing became serial manufacturing. It was already not unique devices, but you need, for instance, some jigs, and the jigs should be resulted in the equal results, in the same results. Jigs should give interchangeable objects, very similar to each other. And because of this, people have changed approach to tooling, not to mounting. It was the same attaching to elements of tooling, but instead of use separate templates which are pulled onto strings, literally templates being pulled onto strings, musician strings, like grid of the strings pass through the basic holes. How this idea of basic holes is appeared at all, yeah? And it was like mounting standard, but it was one-time usable mounting standard. You have assembled it once, and you spent maybe some hours to assemble this composition structure inside of the frame of jig. And next, you dismantle it again. What if you'd like to check your jig in some years, for instance? It means that you need to assemble this structure again inside of jig, but when you assemble it again, it's already not the first time structure. It's a little bit different. And when people understand it, they just start do what you see in the picture. Yeah? This one is pinkish device. They just united system of templates instead of strings. They united into frames, and these frames, what you see, once again remind you this photo. No? These frames, stiff frames, help us to save permanently, constantly in the same positions the system of templates and gauges Gauges or junctions. What are gauges or junctions? I hope you do remember. They are imitators of junctions, like in the ideal best way, they imitate position of holes and position of surfaces in junctions. And additionally, what is good in this technique, of coordination, very high accuracy by junctions. Of course, very high accuracy by contours, compulsory, but by junctions also. I even dropped you here this picture, very little one, do forgive me. It's a photo from our book, from our old book about airspace. What do you see here? You see system of mounting standards. What that red thing that we just have seen, the imitator of the wing shapes. And do remember that it does not imitate, mounting standard does not imitate everything. Mounting standard imitate only some. Sylvan, screen has disappeared again, yes? Oh,
For
Sylvan,
me, no.
hello.
For me, I can see the screen.
Maybe not even screen has disappeared. Maybe me is disappeared. At all. Sylvan,
Ma'am, can you hear me?
guys. Silvana, Vara, Anna. Hello. No, you are not talking. I'm not hear you. You're talking by phone or you're talking to me, Silvan?
I can hear you,
Silvan,
madam.
speak to me. Silvan, I can't hear you because you forgot to switch on. What now I may hear you. Anna, help me. Screen is not visible, yes?
Your screen is not visible.
And moreover, after interruption, it appears that we have no record. What do you imagine? I have just noticed this after screen has
Ma'am,
disappeared.
can you
Noticing
hear
that.
me now?
Yes, now I may hear you. You forgot to switch on mic, Silvan.
No, I'm talking.
Yes.
I'm screaming for the past 2 minutes.
Silvan, look, in my picture, it was shown that your mic is switched off, like now, for instance. No, you know, when I'm... Вот смотри, look at this. I switch off mic now.
No, I understand. I understand. There may be some
And
problem.
it appeared the picture of cross-sected mic. Так, people, let's do interruption. Anyway, record is already interrupted, and it means that maybe I need to come back at some moment again to repeat the